All right, MCT4C day 30. Last day's goal, we're going to practice in the 3 here using graphs to solve some of these problems. In this case, we want to use the graph given to estimate the solution to the equation 10 to the exponent x equals 200. So there's 200 there. And basically what I think, and whether you actually draw this in or not is kind of up to you, is you go over from 200, bounce off the graph, go down, adjust that a little bit maybe, and then write down that value of x. And for me, it looks like it's maybe x is about maybe 2.3-ish. And so it says use your scientific calculator to check and see how close you were. Well, we want to put in 10 to the exponent 2.3. And again, whatever calculator you're using, 10 to the exponent 2.3, pretty close. Pretty good estimate, 199.5. So we're actually pretty close to the answer. And we're going to talk about today how to get even closer, and in some cases exact. 4.3, solving exponential equations numerically. Yesterday we did graphically, and we'll see today we're going to use those techniques sometimes as well. It says use systematic trial. This is the fancy name for guess and check to solve this equation. And what's nice is we already have a guess, right? So the idea of systematic trial is you use one guess to influence your next guess. So our first guess, we had 2.3, gave us 199.5. So we know it's got to be a little bit bigger. But if I go all the way to 2.4, then I put into the calculator. I'm not going to show you all these. You don't have to stare at me watching or using the calculator all class. 10 to the exponent 2.4, and I get 251, which is way too high. So I know it's going to be just over 2.3, and then I adjust my next guess. Maybe I try 2.31, and even that, it is too high. Well, that means it's between this value and this value. So what's between those two values? I'm going to use 2.305 right in between, and that's too high still. And I can see, that it's now between these two values, and I'm getting pretty close to the answer here, and I keep adjusting. I keep adjusting my answer until I'm satisfied that I'm really, really close. Maybe as soon as I can round to the nearest unit, like in this case, I'll be satisfied. So therefore, x is about 200.44, and that would be the solution to this equation. This is the systematic trial, but you probably refer to it as guess and check. This is different, no calculators. And we kind of used this idea yesterday or the day before, perhaps, to solve some equations. Notice this very, small exponential equation, 3 to the exponent x equals 3 to the exponent 6. Two powers with the same bases are equal, right? The bases are equal, so what must be true is the exponents must be equal as well, right? The bases are equal, the exponents must be equal, so I can just say x equals 6. Easy peasy. It has to be true. And here, notice I don't have the same thing, but 81, if I remember, is a power of 3. And this was the trick we were pulling the other day. Let's write 81 as a power of 3. Well, it's 3 to the exponent 4, and how would you get that? Well, I'd try and multiply up. 3 times 3 is 9, times 3 is 27, times 3 is 81, or you could check that on a calculator. And as soon as I have both sides with the same base, then the exponents are equal, and I can finish her off. This one seems weird. How do I write 1 as a power of 5? This is 5 to the exponent something, but what's this something? Well, to get 1, remember, anything to the exponent 0 is 1, and this is just a fact you need to remember, so therefore x is 0. And on we go. Well, 32 is 2 to the exponent 5, so it's 1 over 2 to the exponent 5. That's going to be 2 to the exponent minus 5. Remember, fractions are negative exponents, and roots, radicals, are fractional exponents. So we've got to keep that straight. There we go. And now I've got two powers of the same base. I got a little bit of work to do still because I've got a grade 9 level equation here. Add 3 to both sides. X is minus 2 is the answer there. And I could check that on my calculator to see if that's true, but it is. Here I've got powers of 7 on both sides. This is 7 squared, but how does it work with all this other stuff? Well, I'm just going to write it in, right? I'm going to copy this down, but I know both sides have to be the same base. 49 is 7 squared, just like that. Well, what happens here? Well, what's the operation when I have exponents on exponents? It's multiply. So I could think of it like this. A lot of you at this point would skip to at least this next step. Now that I got two powers with the same base, I can equate the exponents. The exponents are the same. A lot of you will skip from this step to this step, or maybe even this next step where I multiply through grade 9 style. And then, put the variables on the same side. Again, this is a grade 9 linear equation now. And you'll have your own, hopefully, good equation solving skills, your style. -3 and 2 is 1. And if I ever make an error in these videos, just make sure you tell me and make fun of me and all that other business. I will make mistakes the odd time, so if something doesn't make sense to you and you check it twice and it still doesn't make sense, chances are maybe I made an arithmetic error, but X is 1/3 sounds about right. How are we doing for time? Feels like we're doing okay. Yeah, 7 minutes. I've got a couple of questions left. Let's pause the video there for part 2.